Hi, welcome to our channel, and we want to see how the reflection of the seismic waves released from the surface artificially travel through the medium and get reflected. Well, assume this is the ground surface. People may be doing different activities on this surface, maybe walking, cultivating, but now this is the time for survey. We assume that this is the surface and they want to make seismic survey, maybe for exploration, for studying of the section of the structure below the surface. And of course, to set the survey, you'll be having the setup of the source of the seismic signals, and then you will be having the receiver somewhere at a distance. Let's say the distance is x. Remember, when these seismic waves are released from the source, they will travel downward within this medium of the first layer, and when they reach somewhere where the acoustic impedance changes, meaning that the medium changes to the other, and this will be the surface of separation, commonly known as the interface, or by the other name due to the reflection can be termed as the reflector. They will strike to this reflector or the interface, and these signals, of course, will get reflected towards the surface, and let's say they reach to the receiver, or known as the geophone, and get detected. Remember that the path traveled by these seismic waves is towards the uh, towards the interface, and they strike on it, get reflected towards the geophone. Assume the thickness of this first layer is h, and then all the way when these waves travels from the source to the interface and to the geophone, they will use the total time. How can we get the equation that describes the total time travel for these seismic signals? Well, we can use these available parameters: the distance of the source to the geophone separation and the thickness of the layer distance, to get the equation that describes the total travel time. How do we do? Here we look the shape of the geometrical structure here formed, and by the law of the reflection, if you draw the normal to this reflector, the angle of incidence is equal to the angle of reflection. You will find that you have formed two right-angled triangles which are equal, such that the distance of this denominator is exactly the same as the distance of the denominator for this other triangle here. And to simplify, if you want to find the distance of one hypotenuse of this triangle, will be obtained by using Pythagoras theorem. And by Pythagoras theorem, we can redraw this right angled triangle and use Pythagoras theorem to get uh, the 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 length of this hypotenuse here, and this is of course x over 2. If we use the Pythagoras theorem, you find that s squared is equal to x over 2 squared plus h squared, and from there you can make s the subject of the formula and s be the same as the square root of x over 2 squared plus h squared. From that, you get that you have obtained the distance s, but the total distance traveled is s towards the interface, and also it has covered the distance s away from the interface but towards the geophone, and therefore the total distance traveled will be the same as the total distance traveled will be equals to 2s. Why 2s? because it has covered the distance s and again s all the way of its path length, and therefore the distance will be 2s, and therefore this distance will be the same as s is here, and therefore it will be the same as 2 square root of x over 2 squared plus h squared. This is the expression for the total distance. But if we want to get the time, time is equal, total time used is equal to the total distance traveled. Then you divide to the velocity of the first layer, and therefore you'll find that time will be the same as 2 square root of x over 2 squared plus h squared. This is the if you divide by velocity, this is the, of course, the description of the time. If we rearrange this equation, then you square, you apply the square each side. You have t squared is equal to 4x over 2 squared plus h squared over v squared. And of course, if we open these brackets, you have t squared is equal to 2x over v. Of course, the 4 will cancel with the 4. You want to have 2x. You will have x over v squared plus 4. It will be 2h over v squared, and therefore the question for the travel time question will be the same as t squared is equal to x over v squared plus 2h over v squared. This is the equation that describes the total travel time for these seismic waves when they travel from the source towards the interface and get reflected towards the geophoron. So this will be the equation, and of course if you draw the graph of the time against the distance of separation x, it will be curved. So just subscribe this channel to get further concept about seismic and the other methods of geophysics. But the next the next lecture will deal with the graphs for this total travel time, and how can you use the graph of the travel time against the distance of the source to the geophone to extract important parameters about the medium or layer. Thanks for listening. Just subscribe this channel. Thanks.